Okay. New environment. Everything's online. 317 because of the COVID-19, the virus. So I'm connected. We recorded with Zoom, but we're having some trouble with that. So I'm going to do a brief whiteboard review. And I'll continue to do these, and we'll see how the recording of the Zoom sessions work. So we did run a Zoom session for this. I'm guessing their load is huge right about now. Okay, so the first thing we did, we have our scenario here, our typical lab scenario, and what we did is we added a switch. So we have switch router 1, switch 1. They're named a little different than this. Switch 2, and then we have router 3. So we have switch 3.1, switch 3.2. This is the IP addressing that was used for the switches. And our concept was to be able to telnet between the switches in order to be able to do our security to connect in. We talked about when you add endpoints, traditionally you would have antivirus, intrusion protection systems, and run a host firewall on your systems. There are a number of things we can do. You can have, people have to log into Active Directory, but if you're logging into Active Directory, you're all the way up here when we talk about the OSI model. Whereas if we can do security at the switch level, if we can create, some protection at the edge here, and when we talk about switches, even though we're not doing it right now, we would also be talking about access points here also. Okay, so we talk about endpoint security, and if we could do it at layer 2, that'd be good. So I'm going to ramble on a little bit about it's quick to identify the students. All of you were quick to identify people and bring your own devices. This idea of a borderless network, Cisco talks about that a lot. It's the idea that you can connect from anywhere. If you're at home, or you're in a coffee shop, or you are in a hotel, or you are, etc., 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 with the internet, say the internet here, we should have, connecting back to wherever our services are, we should have borderless. So we retain security even though our clients or our employees can be almost anywhere and do their work. Like at Curry's, if somebody's walking around with a tablet in the building, they should have transparent connection to everything that they have authorization to have connection to. And this single sign-on concept of once they log in, they should be able to move to different layers of security and what they're authorized to do. So it's the idea of function without having to think about connecting into the network once you're connected. Wow, it took me a long time to explain one simple thing. Okay, there are some products out there, all kinds of, advanced malware. Cisco has a product, advanced malware. There's all kinds of email security. The college now is using 365. They also have a Barracuda box that's supposed to screen all the email. It does a good job as far as I can tell. I gave the example, if you don't put a subject in, it won't forward that email to me. There's ways to secure web servers and web to better secure that because you have so much access in and out of that. Now, the first part of the chapter, and I call it network access control. That's the generic term. Cisco calls it network admission control. It's basically the same idea. What can we do to control admission to the network? Cisco, in the first part, has products here. So you don't need to spend a lot of time digging into those products, but the concepts we should understand. For example, at NIAC, when you connect to the Wi-Fi, it checks a radius server and decides if you can get in. So it's really kind of like at layer 2. 802.1x is the protocol. Rather than having to identify with Active Directory directly, if that's a funny way to put it, you check with the radius server. And FYI, radius and Active Directory can sync. So you can still do a single sign-on concept, but manage it initially for certain things like Wi-Fi through a radius server. Okay, a little bit of switch review. We talked about port security, monitoring ports, VLAN hopping, or extra tagging, double tagging, VLANs. We talked a little bit about private VLANs where you can have 2 connections and you can set it up so they cannot talk to each other. The curriculum draws one of these like a little with a line through it. Those 2 devices cannot communicate through the switch, but they can still communicate out. So if you put all your ports in private VLANs, they call it, or protected is another term they use. So we can do that. We talked about content addressable memory and how that works a little bit directly. It doesn't really have to go to a table. The port number is tied directly to that MAC address that's in there. DHCP snooping, DHCP starving, where somebody can put on a device that's a DHCP server and then access, use it to distribute addresses, which then it can use itself as a default gateway and run all the traffic through there. So that'd be a man in the middle. We talked about adding a switch or some kind of device that mimics a trunk. If you have dynamic trunking protocol running, then once they create a trunk, then they can send they can see all the VLAN traffic through the switch. So there's simple ways to do that. You can turn that off, you can do some port security and so forth. Yeah, the flooding MAC addresses to get the switch to start to broadcast. Some older switches, I'm not sure about the current ones, would do that. Okay, so to sum it up, we have the new setup for the labs here, and we have discussed, it's a long chapter, but we kind of summarized it all right here. Concept is, if you can secure closer to where things are connecting, it's better than trying to manage it at server levels here. Hopefully that makes sense. And that's it.